you look, your objectives for today are to be able to define what a covalent bond is and to describe to me what circumstances would cause a covalent bond to form. So what types of atoms would be involved? What does that bond look like? Okay. And then you should be able to differentiate between polar and nonpolar covalent bonds. So there's two different types of covalent bonds. One is polar, one is nonpolar. You'll need to be able to tell me the definitions of what they are and how they're different from each other. And finally, you'll need to be able to tell me the number and type of atoms that are in a molecule by looking at its chemical formula. Okay? Some of you, that might be a new skill. If you've been in my class before, you've likely done this before. So if you can't do one of those three things by the time we get to the end of class, you should come and have a conversation with me because you missed something. Okay? And then when we're done, we will have the check for understanding to see if you did, in fact, grasp the content. All right. Launching right into things. Recall from the previous section and from our discussion during the bell ringer that atoms form chemical bonds to become more stable. Okay? Some atoms, like the noble gases, are stable already, and that is why they tend not to have reactions with things. Okay? Atoms are most stable when they have the same number of valence electrons as noble gases, which is 8, or in the case of hydrogen and helium, 2. One way that atoms can achieve stability if they do not already have it is to share electrons, which would cause them to form a chemical bond. A chemical bond that is formed when two atoms share one or more pairs of valence electrons is called a covalent bond. So, in the bond we just discussed, where they're sharing electrons, that is a covalent bond. Covalent bonds are formed only when all the atoms involved in the bond are nonmetals. Okay, if there's a metal involved in the bond, it will not be a covalent bond, and we'll discuss what type of bond that is in the next lesson of notes. But if they are all nonmetals, then it will be a covalent bond. So, for example, hydrogen. Hydrogen normally has one electron. Because it only has the inner shell, having 2 electrons would make it stable, which means it's going to form one bond, and it's going to share its electron with the other atom, and that atom's going to share its electron with it, and as a result, hydrogen will have 2 electrons and be stable. Why did it do that? Oxygen, on the other hand, has 6 electrons in its outer shell, and it would be stable if it could have 8, like a noble gas. So it's going to form 2 bonds so that it can share 2 pairs of electrons. And when 2 hydrogen atoms get together with 1 oxygen atom, then all of them have the correct number of electrons to be stable, and they form a compound called water. So I'll be right back to this page, but I'm going to just show you kind of what that looks like. Okay? So the electron dot diagrams that we drew in the previous chapter are really helpful for showing basic ideas of how bonds form. Okay? So what we're going to do is we're going to just draw the electron dot diagrams for oxygen and hydrogen. Okay? So we have oxygen here. Okay? Oxygen has 1, 2, 3, 4, 5, 6. So you'll notice that it has 2 unpaired electrons, right? And hydrogen, if we draw it, only has 1 valence electron. Okay? So what happens is when these guys share their pairs of electrons here, this is where the bonds form. Okay? And now that pair of electrons that's being shared can be counted for both atoms. So if we count up how many electrons oxygen has, we can count up and say 1, 2, 3, 4, 5, 6, 7, 8, and it has all 8 that it needs to be stable. And if we're counting for hydrogen, we can count 1, 2, and it has what it needs to be stable. 1, 2, this hydrogen has what it needs to be stable. So by sharing them, both atoms can count both of those electrons as belonging to them and be stable. And so this is why you need 2 hydrogen atoms to bond with that oxygen atom to make it stable, and why we get water, H2O. Some covalent bonds share more than 1 pair of electrons between the same 2 atoms. Okay, so what we just looked at, where they're only sharing 1 pair of electrons, is what we call a single bond. Okay? But it's also possible for 2 atoms to share 2 pairs of electrons, which we would call a double bond, and it's possible for them to share 3 pairs of electrons, which we would call a triple bond. So if we want to look at examples of this, okay, we can, for a double bond, we would look at carbon dioxide. So where we had a carbon atom and 2 oxygen atoms. Okay. So remember that oxygen has 6 valence electrons. So we'll draw those on for oxygen. Okay, and then that carbon, if we look at the periodic table, is in period 14 or in group 14, which means it has 4 valence electrons. So it would just have 1 on each side. So what results is that these guys are going to share 2 pairs of valence electrons with each other and form what we call a double bond. So sometimes instead of drawing all of these dots, which can become confusing to look at, right? Sometimes they will draw 2 lines instead. So the lines would represent the shared pairs of electrons. And then we could draw that these guys have 2 unshared pairs that were paired up beforehand. Okay. So lines in a drawing like this represent shared pairs of electrons. So notice that each carbon atom is sharing 2 pairs with each oxygen atom, which is what we would call a double bond. And then if we want to look at a triple bond, we can use nitrogen. So nitrogen gas is not just single atoms of nitrogen floating around, but sorry, don't know what's up with my throat today. But it is in fact 2 nitrogen atoms bonded to each other into a molecule, and then there's a bunch of those molecules floating around. So what that would look like is nitrogen bonded to nitrogen. Nitrogen is in group 15, which means it has 5 valence electrons. So we can draw those on. And then over here. Okay. So these guys would need to share 3 pairs of valence electrons in order to be stable, and each have 8. And we could write this with 3 lines in between and show them with their unshared pairs as well. Okay. So that would be what a triple bond looks like, 2 atoms that are sharing 3 pairs. All right. Okay. Now let's talk about covalent compounds. We know that a compound is the result of a bond forming. So a covalent compound is the result of a covalent bond forming. Though they are different from each other in many different ways, there are some things that most covalent compounds have in common. So just like all nonmetals had similar properties and all metals had similar properties, all compounds formed by covalent bonds have some properties in common. Now, that's not to say that there aren't outliers that don't fit this mold, okay? Just like there are exceptions to every rule, there are exceptions to the common properties of covalent compounds. But most likely, if you were to discover a new covalent compound, it would have some of the following properties. They usually have a relatively low melting point. So sugar is a covalent compound. You can melt sugar on your stovetop. Because they have low melting points, they are usually gases or liquids at room temperature. Some of them are solids, but most of them are liquids and gases. And they are poor conductors of electricity and thermal energy. If you think about it, that makes sense, because what types of atoms are forming covalent bonds? Anybody remember? We said only nonmetals are forming covalent bonds. If you remember, nonmetals are not good at conducting electricity and not good at conducting thermal energy. So it makes sense that compounds made exclusively of nonmetals would have those properties. Pause there for a sec. The most basic unit of a compound is called a molecule. Okay? A molecule is a group of atoms held together by covalent bonding that is an independent unit. So if you're talking about a molecule, you're talking about a piece of a covalent compound that is the smallest group of atoms that form that basic unit. All molecules of the same substance are identical to each other. Okay, so one molecule of sugar will look exactly the same as another molecule of sugar. Okay? To find out what is in each molecule of a specific substance, you need to know the chemical formula. The chemical formula is a group of chemical symbols and numbers that represents the elements and the number of atoms of each element that make up that particular compound. Example of this. Okay. H2O, as we discussed earlier, is water. 2 hydrogen atoms bonded to 1 oxygen atom. Okay. This H2O is how we would write it. So in this case, the symbol H is meant to represent that there are hydrogen atoms in this compound. And then that little subscript number 2 means that there are 2 of them. And then the O indicates that there's oxygen in it, and the fact that there is no subscript on the O indicates to you that there is only 1 atom of oxygen in this compound. So 1 molecule of water, the smallest unit of water, is 2 hydrogen atoms and 1 oxygen atom. The last thing we need to talk about is polar versus nonpolar. So remember that covalent compounds are formed when electrons are shared. However, just like children in a daycare, atoms don't always share things equally. So the electrons are not always shared equally between the 2 atoms. Okay? When electrons are shared unequally, then molecules are polar. Polar molecules are molecules that have a partial positive end and a partial negative end because of unequal sharing of electrons. The partial charge on these molecules affects their properties, okay? Which means if you have something polar, like water, it can dissolve another polar substance, like sugar. But if you have something that is not polar, it will not dissolve in a polar substance. Okay? The reason that polar dissolves polar is because of those partial positive and partial negative charges. Okay, so the partial charge, positive charge on a water molecule pulls on the partial negative charge on the sugar and helps pull those atoms apart, and then the sugar can get spread out in the water, and that is how it dissolves it. But like we said, nonpolar molecules cannot dissolve polar molecules, and polar molecules cannot dissolve nonpolar ones. If you ever heard someone say the phrase like dissolves like, this is what they're talking about. Polar dissolves polar, nonpolar dissolves nonpolar, but it doesn't work the other way around. I will come back to this page, but I'm going to very briefly show you what I'm talking about when I'm talking about polar. We're going to go back to water, because water is an excellent example of a polar molecule. Okay, so we have that oxygen atom, right? It's got its 2 unshared pairs of electrons, and then it's got hydrogen that it's sharing electrons with, okay? So For reasons that are beyond the scope of what we're discussing in class, oxygen can pull on those electrons harder. Imagine an unbalanced game of tug of war, okay? Which means those electrons are going to spend more of their time around the oxygen atom than they are around the hydrogen atom, which means that the oxygen end of the water molecule will have a partial negative charge on it, whereas the hydrogen end will have a partial positive charge because the electrons spend less time around it. And this creates slightly positive on one side, slightly negative on the other, and that is what we call polar, okay? Whereas there are other molecules, so for example, when you had that nitrogen bonded to the nitrogen, because they are the same atom, neither one of them pulls more strongly than the other, and as a result, those electrons are shared evenly, which means there is no partial positive and no partial negative anywhere on this molecule. All right, that is where our notes end for today.